This week we're going to be talking about river processes, and the term you need to know for that is called fluvial, and that is the term that geographers use when we talk about stream-related processes. There's two main things that you're going to need to know for the tests and the mastering exercises, and that is stream transport, which I'll show you the animation for, and also the various stream processes related to how rivers and streams shape the landscape. That's kind of the main focus of this chapter, and so that's one thing the animations are going to show you. So, as I said, stream-related processes are what we call fluvial, and river is the mainstream, and stream is kind of a general term that indicates, you know, kind of the whole spectrum, but river is the main thing we're going to be talking about today. Now, river systems are the network of tributaries that create the watershed, which I'll show you an example of, and then hydrology is the study of water and its global circulation and distribution. Okay, so now surface water initially moves down slope. Okay, so always keep that in mind, pulled down by gravity, and as it does so, it erodes the landscape on the sides and on the bottom. Okay, now this is the drainage basin. So you have a high point, and then that high point separates the various watersheds from, you know, all the water on this side will flow to the left, all the water on this side will flow down to the right. So you have your rills and your gullies, the very smaller ones, these are the tributaries into the streams and then the river itself. So notice again, this is the watershed for this river system. So all the precipitation falls within this red boundary ends up in this river system, and the same thing over here. And watersheds are generally separated by these high points as indicated here. So there's your drainage basin, there's your valley, and the drainage divide. And then there's how it kind of looks like in a real world situation there. You can see the water, here's the divide, so the water within here will flow down to this stream, and the stream will eventually flow into a river or flow into the ocean. Okay, so that's your watershed. It collects the water and sediment from all the tributaries. There's always a headwater, that's the beginning of the system. And as I mentioned, the drainage divides form on the higher land that separates the drainage basins. On a, you know, you can have these at the micro level, you know, like within communities. You can have them at the continental level, like we have here in the United States, and these are usually mountain ranges separate drainage basins in the US and Canada. I'll show you in another slide. And so this sends the water within the US and Canada to the Pacific, Gulf of Mexico, Atlantic, Hudson Bay, or the Arctic. So that's what this looks like. So here's the Rockies here, Appalachian Mountains over here. So those are the two continental divides in the US. So all the water on the left to the west of the Rockies flows to the Pacific. All the water on the east of the Appalachians flows into the Atlantic. Everything in between in the United States is part of the Missouri, Ohio, Mississippi River system, and that flows into the Gulf of Mexico. Up here, all this in Canada flows to Hudson Bay, and all this up here flows into the Arctic Ocean. So you can see, you know, but within each of these, here, let me show you the Mississippi one, but within each of these, so here's your continental ones, but within each of the sub-regions here, you have, you know, individual rivers like the Mississippi, for example, but then all those have tributaries and so forth. And that's what this looks like here. So here's the headwaters of the Mississippi in Minnesota. So way, 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 way up here, that's where the Mississippi River starts. Notice the continental divide. So that's the headwaters, and it starts flowing downhill from there. Then it flows down where it joins, the Missouri joins it, and you can see that's where those two rivers go. And let me show you that. Right here, Missouri flows through here and joins the Mississippi there. And the Ohio joins it right there. Then they flow down past Pittsburgh and eventually into Louisiana, and this is the Mississippi River Delta. So all that sediment that it gathers starts gathering up here, picks up all the way down on that journey from all the way to Minnesota down to Louisiana, and all the sediment from the Missouri and all the sediment from the Ohio River and all their tributaries. All that is carried down and is deposited there in the Mississippi Delta in the Gulf of Mexico. So all this is the watershed for the Mississippi. All the precipitation that falls within this boundary flows into the Mississippi River and eventually down to the Gulf of Mexico. So you can see the Mississippi, again, starts way up here in Minnesota. Here's the Ohio River right through here. And one of its main tributaries is the Allegheny River. Starts up there in New York, right up here. Flows in the Ohio. Ohio flows into the Mississippi, and the Mississippi flows into the Gulf of Mexico. So all the sediment that's captured in this whole watershed flows down through here and is deposited down here in the Gulf of Mexico. Amazon River is another one. Amazon River has the largest discharge, meaning its flow rate is the highest in the world. It's not necessarily the longest, but it's the most carries the most volume. And this is its watershed. This is the Andes Mountains over here, but it's in the rainforest. So all that heavy rain that falls here in Brazil is collected and flows down through the Amazon into the Atlantic Ocean. There's just another way of looking at it when just looking at that. I have some Portobello. I'll show you a slide of it here in a second. But it starts way up here. All this flows down through all these little smaller rivers, the Negro River, the Purus River, the Madeira, for example. These all flow into the Amazon and eventually into the Atlantic. There's Portobello there. Now, anything in this color, the magenta, that's land that's cleared. And this is being land that's cleared for cattle grazing to provide beef, especially for fast food restaurants here in North America. So this is what's leading to the destruction of the rainforest. But again, traffic can come up the Amazon River. It's so wide, traffic can get up here and settle these very remote cities. This is kind of a tricky question, but where do you think this is? So you can see the divides here. So any moisture flow down. Here's another one here. So any moisture would flow down into these larger tributaries. Here's another one here. Any guesses where this is? This would be on Mars. Of course, there's no water there now, but most scientists believe that there was, and the evidence why they think that is the remnants of these stream channels. Now it works on an international basis. Here's the Danube River right through here. Starts over here in Germany, Austria, Hungary, down to Croatia, Serbia, Romania, and into the Black Sea. And all that sediment collects along the way. It's deposited here on the Black Sea. And again, so you get your own unique ecosystem, just like we get in the Mississippi River Delta down in Louisiana. Okay, so let's stop here and then we'll cover drainage patterns in part 2.